On July 19, 2024, CrowdStrike pushed what looked like a routine content update. Within hours, around 8.5 million Windows computers were crashing. The file was small, and the bug behind it was even smaller. One part of the system expected 21 inputs, while another supplied 20. But that mismatch alone does not explain how airports, hospitals, banks, supermarkets, and airlines ended up staring at blue screens. To understand what happened, we need to follow channel file 291 through Falcon into a critical Windows path, past the systems that approved it, and finally into a recovery process that worked well enough on one computer and terribly at global scale. There is also one detail that makes the story feel oddly familiar. CrowdStrike's CEO had already lived through a remarkably similar failure. Bad luck, an industry pattern, or tech history running out of new plot lines. CrowdStrike is one of the largest cybersecurity companies in the world. Its main product, Falcon, is used across banks, airlines, hospitals, governments, and thousands of other organizations. That reach is what made the product valuable, and what gave one bad update such a large blast radius. Airports went back to handwritten boarding passes. Hospitals lost access to digital systems. Supermarket checkouts froze. Broadcasters lost teleprompters and video playback. These were not random home computers losing a Friday afternoon. They were machines buried inside operations that are supposed to be boring. The blue screen was only the symptom. The more interesting question was why a content file could reach deep enough to crash Windows at all. Falcon is an endpoint detection and response platform. It watches processes, files, memory activity, and suspicious behavior so it can stop attacks quickly. That job requires deep access to Windows, including components that operate close to the kernel. Falcon also receives small content updates throughout the day. These help it recognize new malicious behavior without waiting for a full software release, which matters because attackers are not known for respecting release calendars. One of those updates was channel file 291. The name sounds like something designed to spend its entire life unnoticed inside a system folder. That plan did not work out. Channel file 291 used a .sys extension, but CrowdStrike said it was configuration content rather than a kernel driver. The real problem was what happened when Falcon tried to interpret it. On an affected machine, the sequence was brutally efficient. Windows started, Falcon loaded, Falcon read channel file 291, a critical process failed, and Windows crashed. Then the machine restarted and loaded the same file again. CrowdStrike stopped distributing the bad content quickly, but the computers that had already received it were still trapped. Here, the machine often crashed before it could stay online, long enough to receive new instructions. The fix existed, but the affected computers could not stay awake long enough to hear it. So what exactly was inside channel file 291? In February 2024, CrowdStrike introduced a new detection template for suspicious Windows activity involving named pipes, a normal way for programs to communicate that attackers can also abuse. Think of the template as a form with 21 fields. The sensor code calling CrowdStrike's content interpreter supplied 20 values. For months, that mismatch stayed hidden because earlier tests and production content used wildcard matching for the 21st field. The system never had to reach for the missing value in the dangerous way. The July update changed that. One of the new template instances used a non-wildcard condition for input 21, which meant the interpreter now needed a value that did not exist. It reached beyond the end of the input array and triggered an out-of-bounds memory read. Inside an ordinary application, that might take down one process. Inside this path, it took down Windows. 21 fields were expected, 20 values were supplied, and the result was millions of blue screens. At this point, the obvious question is how a mismatch like that made it through the update pipeline. CrowdStrike had a content validator and channel file 291 passed. The company had tests, automated validation, and earlier content using the same template type had worked. The problem was that those safeguards shared the same wrong assumption. The validator evaluated the content as though all 21 inputs would be available, while the sensor supplied 20. The tests missed the exact non-wildcard path that exposed the mismatch, and the interpreter lacked the runtime protection that could have stopped the invalid read safely. Once the file cleared those checks, the rollout gave the system very little room to discover the mistake gradually. A small canary group could have turned the first blue screens into a contained incident. Instead, the customer base became the test environment. Production became the canary. Then came the recovery, and the instructions were almost offensively simple. Start the machine in safe mode or Windows recovery, open the CrowdStrike folder, find the file beginning with C-00000291, delete it, and restart. On one computer, that can take a few minutes. Across millions of computers, the same procedure becomes a worldwide scavenger hunt for people with admin access, physical access, and preferably comfortable shoes. Some devices could be recovered remotely, but many crashed too early. Technicians had to physically reach airport kiosks, hospital workstations, supermarket registers, office laptops, and servers in locked rooms. Then BitLocker made the situation worse in a completely logical way. BitLocker encrypts Windows drives and can require a recovery key before a technician can access the system through a special recovery path. That is useful when someone steals a company laptop. It is considerably less useful when the recovery key is stored on an internal server that is also down. In some organizations, the key to the broken machine was sitting inside another broken machine. The fix itself was simple. Scaling it was the disaster. Microsoft later released tools to automate parts of the process, and CrowdStrike developed additional remediation options. Recovery improved, but the outage did not hit every company equally. Delta became the clearest example. The airline said the incident disrupted systems used to track crews and operations. Delta later reported around 7,000 canceled flights. Other airlines recovered faster, even though they had received the same faulty update. During the recovery, CrowdStrike CEO George Kurtz appeared on television to apologize.
We're deeply sorry for the impact that we've caused to customers, to travelers, to anyone affected by this, including our companies. So we know what the issue is. We're resolving and have resolved the issue now. It's recovering systems that are out there. And essentially, as you've talked about in the statement I put out, is the system was sent an update, and that update had a software bug in it and caused an issue with the Microsoft operating system.
And Kurtz had been close to this kind of incident before. In 2010, he was the chief technology officer at McAfee when a faulty antivirus update misidentified a critical Windows file and sent affected machines into restart loops. The companies and technical causes were different. This does not reduce two complex incidents to one person. It shows how long the industry has lived with the same uncomfortable combination of deep privilege, fast distribution, and recovery paths that depend on the machine remaining usable. After the outage, CrowdStrike announced stronger validation, runtime protections, staged rollouts, and more customer control over content updates. Those changes point back to the same weakness. Once channel file 291 received a green light, there was almost nothing left in the pipeline capable of containing it. A safer system assumes that one layer will eventually fail. It limits the first release, watches what happens, and keeps the recovery path outside the blast radius. CrowdStrike's update pipeline was built to move protection quickly. On July 19th, it moved the failure just as efficiently. Channel file 291 and the mismatch behind it were both small, but the recovery was anything but. The software arrived automatically, while people brought the world back online one machine at a time. That contrast is what makes the story worth remembering. Most days, an automatic update is invisible. On this particular Friday, it became the most visible thing in the world. Now, if you like this video and want to hear more stories from the world of technology, subscribe to the channel. See you next time.